I would like to study the increasing, decreasing behavior and concavity of this trigonometric function f of x equals to cosine of 2x plus 1 at x equals to 6. So the concept is, suppose we have a curve represented by f of x. So this is f of x. This f of x is increasing from x equals to a and x equals to b, and then the curve is concave down. Concave down, imagine you have a bowl facing downward, that is concave down. A bowl facing upward, that is concave up. A function that you can think about is f of x equals to x squared, so that is a parabola facing up, that is concave up. And then if you have f of x equals to negative x squared, then the parabola is facing down, that is concave down. So the function is asking, I have a curve from one point to another point. They didn't mention that, just imagine you have a curve. When x is equals to 6, you have a point. There is a point on the curve when x is equals to 6. I want you to tell me, at this, when x is equals to 6, is the curve increasing or decreasing? So to study increasing or decreasing, we have to get the first derivative. So the first derivative is f prime of x equals to the derivative of cosine is negative sine, right? So we have negative sine of 2x, and then the derivative of 2x is equals to 2. The derivative of 1 is equals to 0. So this is one function to describe the slope of the given function. Again, one function, f prime of x, to describe the slope of the given function at any x value. Okay, if you want to be specific, at x equals to 6, you have to plug in, when x is equals to 6, we have negative 2 times sine of 2 times 6, which is equals to 12. And then you will have to evaluate this. So this one, it is not an application problem. I will have to ask you to use radian mode. Every calculator has a mode key. So if you are using a TI-84 Plus graphing calculator, the mode key is right next to the second key. The second key must be in blue. The second key is in blue. If you look to the upper left hand corner, do you see that there is a second? That is in blue, right? So right next to it, there is a mode key, and then you click the mode. You make sure the mode is in radian, not in degree. We use the degree mode in application problem only, because when you say 90 degree, you say 90 degree, right? You don't say the angle measurement is pi over 2, because people who never took trigonometry, they don't know what pi over 2 is. You have to tell them the angle measurement is 90 degree. All right. So you use the mode key, and then you type negative 2 times sine of 12. That is approximately equals to 1.07. So that is approximately equals to 1.07. The value doesn't matter. What matters the most is that it's greater than 0. So slope greater than 0. So we have a slope greater than 0. That means the function is increasing. F is increasing at x equals to 6. Okay, it's increasing. We are talking about one specific point. I'm not talking about 5, 7, I'm talking about 6. When x is equals to 6, the function is increasing. And then regarding concavity, so let's use a different color for concavity. So for concavity, you have to go to the second derivative. Second derivative of x. And then this is based on what? This is based on the first derivative, right? So the derivative of sine of 2x, that is equals to cosine 2x. And then we have a 2, right? So negative 2 times 2, that gives you a negative 4. This is one function to describe the concavity of the given function at any x value. To be specific, when x is equals to 6, you have negative 4 times cosine 2 times 6 is equals to 12. Same thing, you use radian mode. Oh, if you want to know how to go from the mode page back to the home screen, you have to hit second mode. So same thing on your TI-84 Plus graphing calculator. Above the mode key, there is a word quick, and the word is in blue. So that's why you need to hit the blue key and then hit mode to go back to the home page. So negative 4 times cosine of 12. This one I have approximately equals to negative 3.2 38, the value doesn't matter. What matters the most is this is decreasing. So that when the concavity is decreasing, that means the function is concave down. F is concave down at x equals to 6. So at x equals to 6, we know two things. The function is increasing and concave down. All right, so if you can try some other value, x equals to, if you have the first derivative, just and what if, right? I should use a different color. So if the first derivative at some x value gives you a negative, that means the function is decreasing. For the second derivative, x equals to a certain value, you get a greater than 0, that means the function is concave up. In case the problem gives you a different value, you plug it in, you get a negative and positive. All right, so that is the end of this video. If you think my teaching fits your learning, give me a like, share, and subscribe. I will see you all in the next lesson. Signing out.